So not too long ago, China launched the world's first quantum satellite, named after Chinese philosopher Mises. Its aim was to experiment on secure long-range data transmission using quantum photons. But how exactly does this work? In order to understand this, we first have to understand what photons are, as well as their properties. Photons are light particles at the quantum level, meaning that they are the smallest possible physical entities of light. A photon can be in one of two states, or spins, up and down. When these photons are not observed or measured by anyone, they will be in a state of superposition, a state of a combination of the two spins. However, when measured, these photons will collapse out of their superposition and will be in one of the two spins. Two photons can be paired together into a state of quantum entanglement, where a state of a single superposition in the pair is formed. In the case of an entangled pair, if someone observes or measures one of the photons in the entanglement, the single superposition of the pair will collapse, meaning that both of the photons will have their spins defined. The most special thing about quantum entanglement is that once the photons are entangled, they remain entangled no matter how far they are apart, and changes in their states, such as the collapse of superpositions, regardless of distance, happen instantly, even faster than light speed since they do not need to travel through time and space. Einstein called this spooky action at a distance, which is what scientists today call quantum teleportation. Now, in the satellite's case, it will first produce pairs of entangled photons, which will be split up and beamed to two stations in China and Vienna, 1,200 kilometers apart. This stream of photons can be used as a key to decrypt and encrypt messages. And just like the ones and zeros in the codes of computers, each photon is one part of the key. What makes this technology so great and useful is that, different from what we use now, any attempts by a third party to intercept and examine the key, thanks to quantum entanglement, will change the photons in the key and make it unusable, since the spins will change when they are observed, and the original parties will be able to spot this attempt and be notified, meaning that it is much more safe and secure than what people use to send and receive information online today. Now, what this really means is that data and information sent between two parties, in this case China and Vienna, will be unreadable by anyone other than themselves. This process of quantum encryption can be the future of data transmission. Personal information, national secrets, or even just simple Facebook messages can be safely sent without the potential of interception by unknown parties once enough experimentation and investigation is done on this scientific aspect.